thing said water is flowing at 4 meters per second in a circular pipe. If the diameter of the pipe decreased to 1/2 its former value, what is the velocity of the water downstream? So the diameter decreased to 1/2 is a circular pipe. If we use the equation of continuity, what can we say? V1 is how much? 4. It's a circular pipe, so we can find the area. The area, 1, what will be? Pi r squared. So will be pi, let's label r1 squared. What will be A2? Pi, and instead of R1, what will be in terms R2 in terms of R1? What will be? R1 over 2 and everything squared, so will be R1 over 2 squared. Is that right? And we can find what? The second velocity. What do you use? Equation of continuity. 2 cross-sectional area, find the velocity in one of the cross-sectional area. This is the way to find it. You have 2 pipes, 2 cross-sectional area. Okay, that's the equation of continuity. Good. The final topic, and one special case, will be the Bernoulli's principle. Bernoulli's principle. Bernoulli's basically is the same or is equivalent to the law of conservation of energy. It's not energy, but it's equivalent to the conservation of energy when we study energy. But instead of energy, we will say the pressure conserved. The pressure at one point is equal to the pressure at another point. What explains the Bernoulli's principle? Let's say that we have here a pipe of 2 different cross-sectional areas. Smaller area here, and then goes to another area which can be bigger on a second height. So not only that this is going horizontally like this, but also suffer elevation. So if I label this the area 1 or the length 1 infinitesimal, this I label area 1, and this I label DL2 and area 2. This will be the height 1, which in this case is the ground, but I can say with respect to this point, and not necessarily will be the ground. Let's say that this is supported. But I can say the height 1, and this is the height 2. I want to find what will be the relationship between the pressure at one point and due to what facts the pressure change. Due to what factor the pressure change. We know already that the pressure can change due to the external pressure and due to the pressure due to the height or depth. But now the fluid also is moving. So we have to consider that factor also. Because with the velocity, the fluid can have different pressure. So, and this is basically what Bernoulli found. Let's say that we have this, since we have a pressure or a force from this, this side, force from this side, I will call force 1. Because always this part of the liquid will exert a force on this section. Or externally, this part will exert a force on this. Imagine that we have a pump and this is pumping. And here, maybe it's open to the atmosphere, or maybe there is another pump. So we will say that there is a force exerted on this cross-sectional area, which I will label F2. By the work energy theorem, the amount of energy to bring from here to here, according to what we learned before, the net work to move the water from here to here will be given by all the work here. So all the forces exerting work. What forces are exerting work here? We have F1, which is positive, times dL1, that gives me the work. The force times, we can say delta L or dL, the displacement. That will be the work. We know that is F dL cosine of the angle. Because it's in the same direction, we can say that the work done by this external force will be F1 minus, or dL1, which we can use delta as well, minus the work done by this one, which is, sorry, plus the work, but is minus the force 2 times dL2. Why did I put negative? It's in the negative direction. In addition to that, what other things is doing work? Gravity is doing work, right? When it's moving upward, the work done by the gravity is positive or negative? Negative. So we can say also that this will be negative mg delta H, mg H2 minus H1. And the net work, what is equal to? What is the net work equal to? The change in kinetic energy. The change in kinetic energy. This is the work energy theorem. So I can say that F1 dL1 minus F2 dL2 minus, instead of mass, I will put that in form or in terms of rho, because it's a fluid.